Welcome to the Blocks and Events session. In this session, we want to define what a block is, how to go ahead and create blocks that become custom screen elements, and we want to talk about block interactions. When a block is being contained in its parent, it needs to be able to receive information about things that have changed regarding the parent. And if something changes inside of the block, we'd like to send a notification or trigger an event that will be handled by the parent so that the parent will know what is happening in the block. So basically these interactions are creating communication in between the block and whatever the parent happens to be. So if we try to define what is a block, it's a container, and it's defining some sort of custom-built screen component. So when we start with a block, it's basically empty, and then we can put inside of that widgets, Silk UI patterns, and other types of blocks, and we can build up whatever we need. So it does become that completely custom-built screen component that we might want to have the ability to create. Now blocks are allowed to respond to lifecycle events, and they need to because a screen is going to go through its normal life cycle, and this block is now a smaller component of the screen. And the block itself is going to go through the same thing because it needs to be initialized. It needs to be made ready so that we can have access to the DOM, and then it needs to be rendered. And whenever the screen that it's part of gets destroyed, it would get destroyed as well. So all of the lifecycle events that apply to screens also apply to blocks. So the blocks are going to be placed inside of screens or inside of other blocks. And whatever the block's parent happens to be, it can receive input from that parent. And if that input were to change after we originally received it, we'd like to be able to react to those changes in the input parameter from the parent. And again, when something changes inside of the block that may affect the parent, we want to be able to define an event and trigger that event, and then it's the parent's responsibility to be able to sense that event and have some sort of reaction to it. So the event will definitely be sent to the parent. The question is, will the parent do anything with that event? So let's look at a practical example so this makes a little more sense. Here we have our to-dos, and we have a list of to-dos. And the list of to-dos is, instead of just having the list handle itself, we have a to-do block that is inside of the list. So here you can see this to-do screen has the common layout, and inside of the content area we've created a list that has a list item, and instead of putting a bunch of things in the list item directly, we've put a to-do block inside of the list item. And what this screen is defining is that, yes, I understand that inside of this screen we have a place where the content is being used, that the source block is going to be a to-do block. And that to-do block is taking in a to-do structure or element, and in this case it is just the same definition as the entity. Now below this it says, because this block has the capability, and it's grayed out here, this block has the capability of throwing a priority change and a star change. So when we drop and place this block inside of this screen, it immediately can see those things are available and then has to define the handlers to be able to handle things that that to-do block can do. So because the to-do block can change its priority and it can change the state of the stars or importance of this particular to-do, this screen needs to have handlers. So this is the to-do screen, so it's calling the to-do priority change to make sure that this to-do screen can handle that change from the block that we are containing. And the same thing for the stars. So that's all the things that this screen is doing to define that the to-do block is there and how it's going to interact with it. If we look at the to-do block itself, the to-do block itself has an input parameter, and here is the entity structure of the to-do. And then it defines two events that can occur, a priority change and a star change. So if someone comes over to this dot and changes the priority from low and green to medium or high, or if someone changes this from unimportant and not starred to starred and important, then those events we would detect those changes. We would need to make the change to the to-do itself and potentially save that. And then once it's saved, basically kick off or trigger the event so that if anything in the parent needed to be able to react to that, it could. So our to-do has its structure, it has the events that it can throw. This priority on click and star on click are actually the actions for these two things to be able to change. So if someone clicks on these icons and has the ability of changing them, then we need to react to that. So here we can see kind of the structure of the to-do itself, and the to-do has a list item content block inside of it. So this is a Silk UI block. So our to-do block is using a Silk UI block inside of it, and then it has the structure of the icon on the left for the priority, which is just the circle. We have the title and the due date as expressions, and then we have an if container to show whether or not it's truly a starred and an important to-do. Now down below, this is where we can see the to-do definition itself. We can see the full to-do lifecycle, and we see that in this particular case we're not doing anything special inside of the to-do lifecycle. And we're also not setting any actions to occur when parameters change. So this is sort of making the assumption that in the parent screen, nothing's going to change as far as the the to-do itself. Otherwise, we would need to be able to react to that change, and we'd need to have an action to be able to handle that. So there's nothing, if we go back and look at the to-do screen, all of the edits that could occur are going to occur in the to-do block. The only thing that could occur is we could swipe the to-do and say that it is done. But it being done might remove it from the screen because it would now become a completed to-do. It wouldn't be just in the list of to-dos. But that won't actually change the way the to-do block is going to render things, because once it disappears from the list, there's nothing that's going to change inside of the block to be able to handle that. So again, we have all of the lifecycle events here, and we don't have anything defined because the block isn't really receiving any changes from the parent that it needs to be able to react to. Now there is this icon. If we want to go ahead and set an icon and potentially make this block reusable by making it public, if we do those things, then this block can actually appear in the toolbox, because the toolbox will, once we have a default icon, we'll be able to display this particular block specifically, and it will know what it looks like. So if we're creating a block that could be reused in many screens or in many places, we can give it a custom icon and then get it inside the toolbox to make it easier for us to use. Now, what happens if someone clicks on the dot to change the priority? If we want to go ahead and change the priority, that on click will go ahead and kick off the priority on click action inside of our block. And the first thing that the block wants to do is go ahead and change the priority. So if the priority was set to low, it'll change it to medium. If it was medium, it'll change to high. If it's high, it'll move back to low. So it's just cycling through the priorities. It sets the priority, and then it updates the to-do in local storage. So it says, let's save off exactly what's occurring, and we'll do it here locally in the device. We can sync later if we need to, but we are updating it locally. And then the next thing we need to do is trigger the priority change event. So we throw the priority change event that has been defined, and then the second that this occurs, now the parent will get notified of this event being triggered, and it will potentially need to react to that. So if we go back to the parent, this is where this to-do priority change is its own action. So this is an action that exists in this screen, not inside of the block, and this screen is going to go ahead and react to the do priority change. Now, if we were filtering this list and we were filtering for all of the low priority things, it started as a low priority. If someone clicked it, it would become a medium priority, and we'd want it to disappear from the list. So we could either, in this action, do some sort of list manipulation to make sure it gets removed or gets changed depending on how it has to, or because this is a list and there's lots of data, we could just refresh the list with the newest data, and that medium one wouldn't be filtered out because we're filtering on the low. So when we think about blocks, it's nice that we have the capability of creating these custom blocks and then placing them inside of screens or other blocks. But anytime we have a block and there's input coming in, things could change. We want to be able to react to changes in the things that came in, and anything that happens inside the block needs to communicate back. So we have these handlers and notifications going back and forth, and that's why blocks and events are so important to each other and why we've put them together here. So in this session, we wanted to define what a block is, how we could go about sort of building up a custom block, and we've spent a lot of time talking about how those interactions can occur when parameters that are inputs to the block coming from the parent might change, and when things change inside of our block, how we can trigger events to make sure that all of the parents would know that something has changed inside of this block. So this can be a very nice thing to do, be able to create your own block, and gives you a lot of flexibility to create really nice UIs and have a lot of control over how that works. But because those components may need to communicate back and forth, it's important to understand how the blocks and events interact. Hopefully this session has helped you understand that better.